All right, hello everybody. I'm going to start off this video real quick with just a review from Module 5, and this was actually number 3 on your Module 5 assignment for the split point method. So I'm going to go over this question real quick. If you want to get that out, you can follow along with me. Also, I want to point out it was pretty obvious that some of us are still using Photomath. You're factoring ways that we have never learned before. And I'm okay with you doing different methods of factoring, but I'm afraid that you're just copying it from Photomath and you aren't understanding what's happening. And I'm just warning you, you will not be able to use Photomath on your assessment. Okay, so make sure you're understanding what you're doing and you're not just copying from Photomath. Okay, so the easiest way to do this problem, because everything is negative, I would just divide through by -1. So if you divide each term by -1, we get positive x squared plus 4x plus 3. But don't forget, when we have an inequality, if we divide both sides by a negative sign, you have to, or a negative number, you have to flip the sign. So that becomes greater than 0. Okay, we've done that a few times this year, but that now gives us a nice, pretty positive quadratic. So to factor, the factors of 3 that add up to 4 would just be 3 and 1. And by the way, this is a lot easier than the way that Photomath shows you how to solve this problem. So 3 and 1, and then that means we get -3 and -1 as our solutions. Now, this is not the answer. We're not solving a quadratic here. We're solving a quadratic inequality. It's not an equation. Now, that is part of your answer, but what you have to do next is the split point method. And if you aren't able to do the method in the chart, you're going to miss a lot of points on your test on exam 3. So you next take those numbers and put them on your x-axis or your number line, however you want to think of it. Mrs. Crane did a really good job of showing you kind of the graphic version of this, and I also uploaded another video in Module 5 that explained this, just a short little 3-minute video, so if you haven't watched that yet, you can watch that if you're still struggling with split point method after this. But from here, I like to do a little tic-tac-toe chart. Ooh, that was not a straight line. Tic-tac-toe chart, so 9 boxes. And then next to those boxes, you're going to put the factors that you just came up with. So one of my factors was x plus 3. The other factor was x plus 1. Those are the factors that made up our quadratic. And then my last row, which is really the most important row, I like to put OA, or overall. Okay. Now the next thing we have to do is test our intervals. You need to pick a number within the intervals on the number line that you just wrote up here to test and see if the quadratic is positive or negative, because the whole point of this question is to figure out when the quadratic is greater than 0, aka positive, right? So if I pick a number to the left of -3, it could literally be any number. Probably the easiest would be -4. So I'm going to choose -4 for my test point here. And this should all be very obvious and visible in your answer. You should show all of this, okay? And then a number between -3 and -1, you could do -2. And then a number to the right of -1, any number to the right of -1, probably the easiest one to plug in would be 0. Okay, now all you're going to do is plug these green numbers into the factors and determine if you get a positive or a negative number. Okay, so if I plug in -4 into x plus 3, 4x, that becomes -4 plus 3, which would be -1, but most importantly, we know it's negative. Okay, now if I plug in -4 into here, that would be -4 plus 1. That would still be negative. -4 plus 1 is still negative. But remember, factors are multiplied together, right? Up here, that's something times something. So a negative times a negative, we know, is a positive. So overall, the quadratic is positive to the left of -3 is what we just found out. Okay, now we do the same thing for the other two sections. So if I plug in -2, this would be positive. If I plug in -2 into x plus 1, -2 plus 1 is negative. And then the middle column here, a positive times a negative is a negative. And then lastly, if I plug in 0, that test point over here on the right side, 0 plus 3 is positive, 0 plus 1 is positive, a positive times a positive is a positive. Now, the most important part is this last row. That's your answer. That's part of what you need to look at for your answer. And in this case, greater than 0 happened twice. It happened over here, aka to the left of -3, and it happened over here, aka the interval to the right of -1. So my final answer is those two intervals. So we write it as the number line above, -infinity up to, and that split was at -3. And because it's just greater than, I'm going to put a parenthesis, not a bracket. That's a parenthesis. Union, and then the other interval in which it was positive was -1 and to the right. So -1 to infinity. And that is your answer to number 3 on Module 5. All right, for the remainder of this lesson, I just have a few examples about, I call it fraction busters, or in other words, eliminating fractions. So the only thing we have not learned on pretest 3, which goes all the way back to the quadratic equation, which seems like months ago, is eliminating fractions. So there's a few of these on your pretest. Other than that, you should be able to complete your whole pretest, okay? So to solve an equation with fractions, it's usually best to eliminate them. And the easiest example of that is this one right here, x divided by 3 equals 7. Now, a lot of us know, well, if it's divided by 3, the way we would solve for x is multiply by 3. But really what you're doing is you're multiplying the numerator by 3. So now what you have is 3x over 3. And 3 divided by 3 cancels out, right? If there's a 3 on top and 3 on bottom, that cancels out, and we're just left with x. But if you do it to one side, you have to do it to the other side. You have to do it to all parts of the equation. So our final answer would be 21. Okay, that's the most obvious form of eliminating a fraction that you're probably used to since all the way back in Algebra 1. Okay, so here's what your college algebra pretest, I think, looks like. In fact, this one might even be on your pretest, but notice there's numerous fractions, okay? Some of them have a denominator of 2, some of them have a denominator of 3, and we even have one that has a denominator of 1, right? Okay, so what I want you to think is, what is the least common multiple of these denominators? Really, 1 doesn't matter. But the least common multiple of 2 and 3 would be 6, right? 2 multiplies into 6, and 3 also multiplies into 6. So what you're going to do to eliminate fractions is multiply all of the numerators by, and I mean all, you can't forget about this number here, every single term in the equation, you're going to go through and multiply it by that least common multiple. Now, don't confuse this with getting a common denominator. We're not getting a common denominator. We don't want denominators. Our whole goal is to get rid of the fractions completely. Okay, so by doing this, 6 over here on the left side, we have 6 times x, so that just becomes 6x over 2. And I'm taking this really slow. Some of you can maybe see what will happen in the future, but I'm going to take it step by step here. Then we have 6 times 5, so we got 30 over 2. And then 6, so minus 6 times 3 was 18. And then 6 times 2x would be 12x over 3. Minus 6 times 1 becomes 6 over 3. So all I did is I multiplied all of the numerators by 6. So next, you can simplify these fractions. Because the numerators have been multiplied by something that divide by 2 and 3, all of these will cancel out. So for example, 6 divided by 2 is 3. Plus 30 divided by 2 is 15. This was minus 18 equals 12x divided by 3. Well, 12 divided by 3 is 4. So 4x minus 2. And just like that, we have eliminated the fractions. Okay, so from here, you can just combine your like terms. So obviously we have 15 minus 18. So that would be negative 3. And then I'm going to go ahead and subtract this 3x to the right side, because then I can see that that's just going to be an x. So we have x minus 2 equals negative 3. And then I just add my 2 over. So now we're just doing a whole bunch of algebra 1. So therefore x equals negative 1, negative 3 plus 2. That was how to eliminate fractions. All right, next we have an inequality version. So we have some fractions here, denominators of 4 and 2. The least common multiple of 4 and 2 would be 4, right? 4 times 1 is 4, 2 times 2 is 4. Both of those multiply into 4. Both of those divide by 4. So once again, I'm just going to go through and multiply every numerator by 4. And don't forget your 1 over here. That is also something. You have to multiply every term by 4. Okay, so this becomes 4x over 4, which we know 4 divided by 4 will cancel out, but I'm showing all the steps here. And this becomes 12 over 2 is less than or equal to 4x over 2 plus 4. Now's the fun part. It all cancels out or simplifies. 12 divided by 2 is 6. And then 2x plus 4. Now, don't forget when you're solving an inequality, the only thing you have to remember is if you multiply or divide both sides by a negative number, then you have to flip the sign. So if you want, you can try to avoid that. So for example, if I subtracted 2x to the left, that would become negative. At some point, I'd have to divide by a negative to get x by itself. You'd have to flip the sign. So I'm going to go ahead and just subtract this x to the right. So this becomes negative 6 is less than or equal to x plus 4. And then I'll subtract my 4 to the left, so we get negative 10 is less than or equal to x. And then I'm just going to flip that whole thing backwards to write x on the left side. It's always best to write an inequality with x on the left. So negative 10 is less than or equal to x is the same thing as x is greater than or equal to negative 10. There's your answer. And this is our last problem for today. It is the quadratic version of eliminating a fraction. So the least common multiple of x squared and x would be x squared. It's the largest exponent of the two. So if I multiply each numerator by x squared, so this is like the variable version of what we've been doing. And even the right side, even though it's a 0, sometimes it's not, so make sure you multiply everything by x squared. So what this comes out to be is 5x squared over x squared minus 17x squared over x plus 6x squared, and that obviously just stays 0, but it's important to do things to both sides of the equation, okay? So you can now see why we did this, because x squared divided by x squared cancels out to just a 1. So 5 times 1 is 5. Minus, here we have x squared divided by x, which is just x. So that would be 17x. Now this becomes an x squared term, and we now do not have any denominators. It's just a quadratic. I'm going to go ahead and write it in standard form. So the x squared term first, minus 17x plus 5, that is a positive 5, so plus 5. And now we're just solving a good old quadratic, which we've done a million times this year. Make sure you're trying to follow the methods that we've learned, and you're not just using photomath. A lot of you messed this up pretty badly on the last module. So pay attention here, make sure you see a good factoring example. So a times c is 30. Now we have to add up to a negative number, so we know both of these need to be negative, because a negative times a negative is positive, but when added together, we'll get that negative 17. So negative 15 and negative 2, those are our winner chicken dinner. So we put those in our factors, so x minus 15, x minus 2. Now those of you that did factor correctly, don't forget you have to divide by a. Remember, that completes the bottoms up, and Mrs. Crane left that comment on quite a bit of your module 5s. So don't forget, when you're doing your bottoms up factoring, you divide by a, and we reduce So 15 over 6 is 5 over 2, because those both divide by 3. And then 2 over 6 is 1/3. And now, remember, bottoms up, you take the bottom to the front of its factor. So we end up with 2x minus 5 and 3x minus 1. If I set each of these factors equal to 0 and solve, I would get positive 5/2 as one answer and positive 1/3 as the other answer. Okay. Now you could check these if you wanted. You can plug them back in. Really, the only thing, and what I mean by that is back to the original problem. Okay. The only thing you have to worry about is that sometimes you'll get an answer of 0. Okay. So if you ever got an answer of x equals 0, you have to take a look at the denominators, or really in any case, with any time you're dealing with a variable in the denominator, because you can't have 0 on the bottom of a fraction. So if we did all of our algebra and we got to x equals 0 as an answer, that would actually be no solution, or that 0 does not work, because that means 17 divided by 0, which we know can't work. And same thing here, that would be 0 squared. Okay, so just be careful of that. If you get 0 as an answer, that one would not work, so you just leave it out in this case. Okay, that is all for our Module 6 video. Pretty short, 16 minutes here.